All right, so we're taking a look at the homework solutions for lesson 14, so let's get into it. First one says, use the graph to find the maximum height reached by the stream of water. So you can picture this graph right here being our stream. So if you were looking at it, where would the highest point be? Well, the highest point of water would be here. So how high are we talking about? Well, that is a distance here on our vertical axis. It even says height. So how high is that at? Well, that would be 4. So the maximum height would be 4 meters. How far from the fountain did the stream of water reach this maximum height? So at its maximum height, how far over are we? Well, now we need to say, okay, well, what's the distance this way? And it says right there, our horizontal distance. So that would be 2. And that actually tells us the coordinates of our vertex, which is 2, comma, 4. So it went over 2 meters. Now, how tall is the base that the fountain rests upon? So now you got to think, okay, well, that sounds like our starting point, because if you're thinking about a fountain, it always starts from a certain height and then starts shooting water, kind of like we are doing right here. So if this is our fountain here and the water's shooting out, we're starting at a height of 1 meter. And that's why you'll see that this graph doesn't start at 0, it starts at 1. So the original height is 1 meter. 4.2. What is the maximum height reached by the ball? When you see maximum or minimum, you need to start thinking vertex. So if I take a look at this graph, what is the vertex of this graph? Right here. So what is the maximum height reached by the ball? If you go over, it looks like it is at 20 meters. When did the ball reach the maximum height? Well, now we need to go down. And it looks like it's right in between 2 and 3, so it would be at 2.5 seconds. Now, how long was the ball in the air? So if the ball started here and went up and then came down, when did it come down and hit the ground? Well, it happened at 5 seconds. So all that information can be gleaned just by taking a look at the graph. Okay, good one here. So 3. Quadratic relation h equals negative 5t squared plus 180 models the path of a ball that was dropped from a height, and they're using h to represent that height. So graph the relation. So easiest way to graph relations, of course, for this is to take a look at a table of values. So we have t and we have h. And we'll just use 0, 1, 2, 3 to just get an idea of what our graph is looking like. So what we're going to do is we're going to put that 0 into this equation for t, and when we do that, our height is going to be 180 if you just use your calculator. The next one, if you put the 1 in, it's going to give you a height of 175. And then the next one, if we put that in, it's going to give us a height of 160, so it's starting to drop quicker and quicker and quicker. And then if we did 9 plus 135, and you see that's starting to pick up pace. So if I have my graph, it looks something like this, and here's 0, 1, 2, 3, and this thing starts from 180, maybe that's 150, that's 120, 90, 60, and 30. So a nice rough graph. You will not do a nice rough graph, you'll do a beautiful graph. But this is kind of how it's going to look. So our first point was at 0, 180. Our next one was at 1, 175, so pretty much right there. 2 was at 160, kind of like that. And then 3 was at 135. So you see that it's dropping off relatively quickly there. And then if we did another one, let's take a look at just one more, just for fun. This one would be at 100, so at 4 seconds, it's at 100, which will be right down here. So you see that it's starting to curve down, and eventually it's going to hit the ground, and that's why we have a parabola. So graph relation is done. So from what height was the ball dropped? We can look at our graph and we can see that it's at 180, or if we didn't want to do that, we can just say, well, how high was that ball when, or before we started, aka when the time was 0. When 0 seconds have passed, that means you started your experiment. How high was that ball at that point? So it was 180 meters. Find the height of the ball after 3.5 seconds. You could look at your graph, but that's not very accurate. A better way is take that 3.5 and put it in there. So that's what we're going to do. H equals -5 and then 3.5 squared plus 180. So for that, you're definitely going to need your calculator. So take out your calculator and let's do the math. And I got a height of 118.75. Okay, perfect. All right, find the zeros of each relation without graphing. Well, we are very good at factoring, and that's what zeros mean. When you see zeros, it means factor. And here we have all simple trinomials, so we're going to be looking at what two numbers and what two numbers. And that was the key, right? We're looking for those magic numbers. So what two numbers add up to 5 and multiply to 6? Well, for this one, it's definitely going to be 2 and 3. So this is just it in factored form. If I want to find the zeros, what I need to do is I need to take these and flip the signs. So what my zeros are actually going to be for this, so we need to flip the signs. We're going to have zeros at, instead of positive 2, we're going to have negative 2. And instead of positive 3, we're going to have negative 3. Okay? So that tells me the zeros of this equation. Perfect. Okay, next one we have what multiplies to -18? Well, we have x plus 9 and x minus 2. So what are my zeros? Don't forget, we need to flip our signs. So we have x equals -9 and positive 2. And then we have what multiplies to 24 and adds up to -10. So we have x minus 6 and x minus 4. So that's going to, remember, flip the signs. X equals 6 and 4. Perfect. The next one. Quadratic relation y equals x squared plus 3x minus 4. Does the relation have a maximum or a minimum value? For this, look at the coefficient of x. So look at the coefficient of x. So here, the coefficient of x is this imaginary number 1, and that means it's a positive number. So if it's a positive number, write this down, positive number, it opens up. And if it opens up, just like it kind of does right there, what value do we have? Do we have a maximum or a minimum? Well, we definitely have a low point, which means we would have a minimum. So if that first number, just like we said, is positive, it's going to open up, which means we have a minimum value. If it is negative, it's going to look like this. If it's negative, it's going to open down. And if it opens down, we're going to have something that looks like this. And now your vertex is a maximum value. Okay, keep that in mind. I'm going to put a box around that because it's important. So does it have a maximum or minimum value? So here we said this opens up, which means it's going to have a minimum value. What is our y-intercept? Here, to find y-intercept, just set x equals to 0. That's how we find all of our y-intercepts. Just pretend that x doesn't exist. So what we're going to do there, so we have y equals x squared plus 3x minus 4. We're going to substitute 0 in, so y equals 0 squared plus 3 times 0 minus 4. You're going to get y equals minus 4. So what's the y-intercept? 0 minus 4 for B. And C, what are the zeros of the relation? So now, remember, zeros means factor. So we can factor this thing, no problem. Two numbers that multiply to -4 and add up to 3. So we're going to have x plus 4 and x minus 1. Don't forget, if we're looking for the zeros, we need to flip those signs. So we're going to have x equals -4 and positive 1. Okay. Perfect. So let's go ahead and skip to number 4 here. Which of these equations does the parabola represent? So let's take a look. What are our zeros? Our zeros are -2 and positive 3. So if we put those in our brackets, remember we're going to have something and we're going to have something. In order to get to negative 2 and 3 for our zeros, what do we always have to do? We always have to flip the signs. So in order to get a negative 2, that means it had to start out as a positive 2. In order to get a positive 3, it had to start off as a negative 3. So are any of these matching up to this? Well, definitely that one. Okay? So don't forget, to go from factored form to zeros, we need to flip the signs. Okay? And the last one here. Write the equation in factored form, so we can factor this no problem. So we'll have y equals, and then we'll have x. So what multiplies to 16 and adds to negative 10? We're going to have x minus 8 and x minus 2. Okay, so that's part A. For part B, what are the zeros? To get the zeros, we need to flip the signs. So our first zero is going to be, when we flip negative 8, it's going to become positive 8. And the other one is going to be positive 2, because it went from negative 2 to positive 2. All measures are in meters. What is the horizontal distance between the ends of the cable? Well, let's just sketch this out really quick so we can kind of see. And we know, does this open up or down? Open up or down? We'll take a look. Is there a negative sign in front? No, there is not, so it opens up. Now, what are our zeros? So if we have 1, 2, 3, 4, 5, 6, 7, 8. We know that one zero is at 2, and the other 0 is at 8. So 3, 4, 5, 6, 7, 8. So those are our two zeros. Okay? And we know that it is opening up. So it's going to look something like that. So what is the horizontal distance between the ends of the cable? So if these are the ends of my cable, right here and right here, what's the horizontal distance between this? This is at 2, this is at 8, so the horizontal distance would be 6. And that's it.